Okay, here's some questions from your Chapter 5 review. So PC 20, Chapter 5 review. In section 5.1, we talked about working with radicals, and we talked about the difference between a mixed radical and an entire radical. So you need to know that for the test. A mixed radical has a regular number part that's outside of the root sign, that's not 1. So it's obviously something other than 1 that's multiplied by the radical, and you have something inside. So these are all, this is a mixed radical. This would be an example of an entire radical because there's no number other than 1 on the outside. Guys, listen up here, please. Okay. So a mixed and entire radical. So in order to convert each of these mixed radicals to an entire radical here, again, you have to think about, is this a square root or a cubed root? And for the 8 to get inside the square root club, it has to get squared. So this is actually, can be rewritten as 5 that's already in there times 8 squared. Okay? 5 times 8 squared. That's how you can get that coefficient from outside to inside the club. So 8 squared is 64 times 5. 60 is 320, I think. 320. So you don't have to know that in your head. 5 times 8 squared, so that's 5 times 64, 320. So this is the entire radical counterpart. Those are the same values, but they're just expressed differently. Negative 2. Okay, so negative 2 can come inside the 5th root club if it's negative 2 to the power of 5. Then it can come inside the 5th root club. So this is the square root of 3 times negative 2 to the power of 5 is negative 32. So that is, don't forget the 5th root there. That 5th root has to be in there. So the 5th root, what's that? Negative 96. And you can have a negative inside a radical that has an odd index. That's okay. Because, negative, let's say negative 2 times negative 2 times negative 2, that's actually negative 8. So the cubed root of negative 8 has a value, namely negative 2. So anything with an odd index, you can have a negative under there. If it's even index, you can't evaluate it if it's got a negative underneath. All right? So that's first two. I'll let you do the rest for number 1. Any questions about number 1 so far? All right. Number 2, going the other way, convert each entire radical to a mixed radical in simplest form. So we want to simplify this radical in a sense that we want to make it into a mixed radical if we can. And that's a very important thing to be able to do, and you have to do that lots in math. So how you go about doing that is you look for factors of 72 that themselves are perfect squares. So 72, all right. You want to think of the largest perfect square too. Like I'm thinking of 8 times 9. So that's good, but there's also a perfect square of 4 inside here, right? So the largest perfect square wouldn't be 9. The largest perfect square would be 9 times 4, or 36 times 2. That's the largest perfect square. That's a factor of 72. So that 36 can now come out of the square root club because it's a perfect square. So that's 6 now, and root 2 is left over. So 6 root 2. Okay, questions there? I'm going to do D as well. It's pretty tough. That's a tougher one, so that you might be more interested in D. The cubed root of 80 times x to the 5th times y to the 6th. So with numbers, again, with numbers like 80, you want to find a factor of 80 if possible that's a perfect cube. And the cubes, you should have some of them memorized and have a list on your cue sheet. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64, and so on. So have a list of cubes on your cue sheet. But notice that 8 is a perfect cube, and that's a factor of 80. So this is 8 times 10. You see that? Now with the variables, it's a little trickier, but if you remember that if this exponent, so in this case it's 5, let me zoom in for you. In this case it's 5. If that exponent is evenly divisible by this index, then it's a perfect, in this case, perfect cube. So 5 is not divisible by 3, but if you rewrite this as x cubed times x squared, then x cubed is a perfect cube. Okay, so here's my perfect cubes there so far. And y to the 6 is evenly divisible by 3, so guess what? Y to the 6 is a perfect cube as well. So you want to split this number up here underneath the radical sign into either perfect squares or cubes or perfect fourths or fifths or whatever this index tells you. Okay? So splitting that up, factoring that in that way is most important. Now what we do is we understand that 8 can get out of the cubed root club, and it comes out as a 2. X cubed can get out of the cubed root club. It comes out as simply an x, right? Because it's x times x times x gives you x cubed. And y to the 6 comes out of the cubed root club as a y squared, because y squared times y squared times y squared is y to the 6. Okay? Or 3 divided by 3 is 1. 6 divided by 3 is 2. So that's where these come from. And then whatever is not able to come out of the club has to stay in. And so just those two entities, and there you go. That's your answer there. Okay? Any questions about mixed and entire form for radicals? All right, hopefully that's making some sense. All right, let's take a look at number 3 here on our review. So if I was asked to simplify this, what you're looking for is you can gather like terms if the terms are like, and they are like if we have the same radical, that is a square root, that's a square root, and that's a square root, and you have the same identical radicand, or the number or term underneath the radical sign. Number or term or terms. So if this is identical, then we can simply combine the numbers in front. So this is a -1 and a positive +2, right? So -1 plus 2 is 1 root 13. Do not add 13 and 13. It's not root 26, okay? Can't do that. And of course you wouldn't put the 1 there because, you know, that's convention is we just leave that blank, so that's just root 13. All right. B, okay, B, you want to try and simplify the radicals first if you can. Then you can actually see if they are like radicals to combine them. So 7, root 7 can't be simplified. But 112, I think, does have a factor that's a perfect square, right? So perfect square factors would be 4, 9, 16, 25, 36, 49, that sort of thing. So what perfect square is a factor of 112? And even if it's not the largest one, you can just pick any one. And then we'll just have to keep simplifying until we're done. And I'm just going to do 4. Let's try 4. Okay, so does 112 divide evenly by 4? Let's just see. 112 divided by 4. I know that's a perfect square. Look at that. It does, 28. So let's say that you started to simplify this and you said, oh, 4. There we go. I'm going to take a 4 out, and I know that that's times 28. So guess what? This right here can simplify. That 4 comes out as a 2. 2 times 2 is 4 root 28. And you pat yourself on the back and you say, okay, that's good, but you have to check again to see if there's still a perfect square factor of what's left underneath there. Because it's not the worst thing in the world not to take the largest square root factor out. But if you don't take the largest square root factor out, it means you're just going to have to do the process again, which is totally fine, but because you see that 28 is actually 4 times 7, right? So now 4 can come out again. 4 times 2 is 8 root 7. So this right here actually simplifies to 8 root 7. All right, so 4 root 7 minus 8 root 7. Now these are like terms, so we didn't see that, but now we see that they are like terms. We can gather them together. So 4 minus 8 is -4 root 7. That should be your answer for that one. And there's the bell to end class today, so that's all the review I'll do here today. Please keep working on that, and yeah, finish the rest of your review, and let me know if you have any questions tomorrow.